Okay, this is paper one, Cambridge O-level paper, and the code is 5054, and the paper is 1-2, May, June 2021, and the time 1 hour. So we have to attempt all questions. Move to question number 1. The question is, a student determines the circumference of the football. So suppose this is the football. And we have to measure this circumference, this one. From this point to this point, we have to measure the length. Now the vernier caliper, which instrument give a reading that is circumference of the ball? So caliper, no. It cannot measure the circumference. It measures the diameter, external, internal, and the depth. Micrometer, no. Ruler, so the ruler cannot be fit around the football. So the answer is the tape measure or the measuring tape, because it is flexible and we can place it at the surface of the ball to measure it. So tape measure, the tape is the best option. So D is the answer. Next is a coin falls from the rest through the air. Yes, this is air, air resistance is considered, and eventually reaches the constant speed. There is a resultant force acting on the coin due to two forces, P and Q, shown in the diagram. What happens to the force P and what happens to the resultant force before the coin reaches the constant speed? Look. First force is the weight, which acts downwards, and during the fall, it remains same. And the second force is the air resistance, which increases with speed, and it acts upward. And the third is the resultant force, which is the difference of these two forces. And which is responsible for the acceleration, because the formula is driving force minus resistive force is equal to ma. So this is the weight. It remains same. This is the air resistance. With the passage of time, it increases. When the weight remains same and the air resistance gradually increases, then the answer of the resultant force decreases. For example, weight is 20 Newton. Initially, the air resistance is 5. So the resultant force is the difference, 20 minus 5, 15. When this air resistance becomes 10 Newton, then the resultant force becomes 20 minus 10. It's 10 Newton. Look, the resultant force is decreasing. So the force P is the air resistance. It increases, but the resultant force is decreasing. So the option is C. So I repeat, weight acts downward, it remains same. Air resistance increases with speed, and the resultant force, the difference of both forces, which are opposite, is the resultant force, and gradually it decreases. That's why the acceleration decreases. And finally, the acceleration becomes 0 for the terminal velocity. Okay, next. The diagram shows the forces acting on 4 identical solid blocks. Each arrow represents a force of 20 Newton. Which blocks are in equilibrium? So forces are equal, but we have to look at the turning effect, torque, the moment. The torque must be 0. Resultant torque must be 0, the clockwise or anti-clockwise must be equal. So suppose these are the pivots. Now the question is, which block are in equilibrium? So look, this force 20 Newton is passing through this pivot, this 20 Newton passing through pivot. So when the force passes, arc is 0 because both forces are passing through the pivot, but both forces are acting in one direction. So this is 20 Newton, this is 20 Newton. So the resultant becomes the 40 Newton, mean the forces are not 0. So here the resultant force is not 0. Here the resultant force and the resultant torque 0. Here the resultant force is 0, but the resultant torque is 0 because there is a net torque. And here both the forces and the torque both are 0. So the answer is P and Q both are equilibrium. I repeat this. Look, this is 20 Newton, this is 20 Newton, both are opposite. So they are canceling each other, mean the resultant force is 0. And the both forces are going to pass through the pivot. So they have no turning effect, no resultant force. These two forces, one right, other left, they are canceling. So the resultant force 0, but resultant torque is not 0 because both forces are trying to rotate in same direction. This direction, clockwise, this direction, clockwise. So there's a net torque. So the resultant torque is not 0. So this is not an equilibrium. And look, these two forces are opposite. Resultant force 0, resultant torque 0 because the forces are passing through the pivot. So this is equilibrium. Here, there's no torque, but both forces are acting in the same direction. So the resultant force is their addition. So not an equilibrium. So P and R are the two cases in which the resultant force is 0 and the resultant torque is 0. That's why the P and R are in the state of the equilibrium. Next, question number 4. A student lists 3 changes that affect the stopping distance of the car. Increasing the braking distance. Increasing the braking force. Definitely, then stopping distance will decrease. Increasing the friction, more retardation, so the stopping distance decreases. Increasing the speed of the car, definitely then speed, it will affect the braking distance and also the thinking distance. So the total stopping distance will increase. The which change are the changes increase the stopping distance. So out of 3 options, only one option 3 is responsible for the increase. So the answer is D. The rest 2 are decreasing the stopping distance. Next, number 5 is the diagram shows a satellite orbiting a planet at a steady speed. In which direction does the resultant force acting on the satellite? Definitely, the satellite is moving in a circular path. So in a circular motion, the resultant force, mean the centripetal force, acts towards the center of the planet, center of the circle. So definitely the A is the option. Okay, the next question is question number 6. The gravitational field strength in space is smaller than the Earth's surface. So when the gravitational field strength is small, then definitely the weight of the object will be small because weight W is equal to mg and the mass remains same and the weight directly proportional to g. A rocket is used to launch the satellite from the Earth's surface into the space. How are the mass and the weight of the satellite affected as the satellite moves away from the surface of the Earth and into the space? So definitely the mass of the rocket will remain same. And due to the small value of the g, the weight will be affected. So weight decreases. So both mass and the weight are affected? No. The mass decreases? No. The mass increases? No. The mass is unaffected? Yes, it remains same, and the weight decreases. So the correct option is D. Next question is, air is trapped in a cylinder by a piston. The piston is moved inward so that the volume of the air reduced. How much? Look, 1, 2, 3, 4 unit. And here it becomes 1, 2. It means the volume decreases by 2. Volume is decreasing and becoming the half. The density of the air in the syringe at the initial volume is 0.012 gram per centimeter cube. What is the density of the air in the syringe at the final volume? Look, the density rho is equal to mass over volume. The mass is constant, mass remains same. So the density inversely proportional to volume. When the volume becomes half, then the density becomes double, mean the double of this. And the double of this will be 0.024. So the option is C. When the volume becomes half, density becomes double because both are inversely proportional to each other. And the next question number 8 is, some forces are applied at the different distances from the pivot. Which diagram shows the force that produces the largest moment about the pivot? So perpendicular distance. So F into D, this is the moment. Now we will write 50 force and this in meters, 0.9. And here it is 30 multiplied by 2. Here it is 80 times 50 centimeter, mean 0.5. And here it is 18 times 3. Now, after the calculation, this is 60, this is 40, and this is 54. So definitely this is the larger one. So the B is the answer. The largest moment is produced in the diagram B. Do convert centimeter into meter for the calculation. And the next is, the diagram shows a children wooden play tower. Which change to the tower makes it more stable? Yes, there are two options. Either lower the center of the gravity of the object or increase the base area. So stability can be increased, can be improved by lowering the position of the center of the gravity. And number 2, by increasing the base area. Now look, making the tower narrow? No. Making the tower taller? No. Lowering the center of the mass? Yes. Center of the mass mean the center of the gravity. So, and raising the center of the mass? No. So C is the answer. By lowering the center of the gravity, center of the mass, center of the weight, we can make it stable. So C is the option. And the next is question number 10. Where on the graph is the limit of repellity of an elastic cord? So limit of repellity mean the end of the Hooke's law. And Hooke's law says extension and the load directly proportional, mean end of the straight line. So this P is the end of the straight line. So this is the limit of repellity, not the elastic limit. Elastic limit and the limit of repellity, both are the different thing. So limit of repellity is the end of the Hooke's law. And the elastic limit is the end of the elastic behavior. So here, the question is limit of proportionality. So end of the straight line. So definitely B answer at P. Okay, next question is question number 11. The weight of the 2 Newton is hung from the spring. The extension produces 6 centimeter. The 2 Newton weight is removed and the 8 Newton weight is hung from the spring. The spring does not pass its elastic is the limit of parity. What is the new extension? Look, the Hooke's law formula is F is equal to Kx. This is spring constant. So this is constant. So F directly proportional to X. And both are directly proportional. So we can write F1 over F2 is equal to extension 1 over extension 2. So initially force is 2, and the later we will use the force 8 Newton. Initial extension is X, and the later is required So when you will calculate this X, the answer is coming 24 centimeter, this one. Next, an object is placed at the depth D below the surface of the liquid of the density rho. On which expression does the pressure of the object depends? Look, the pressure is equal to rho g h. This h is not height, this is depth. G is constant and this density. So it depends on these two variables, density and depth. So the density and depth is in B. So B is the answer. So the product of density and depth will affect the pressure. Number 13 is the diagram shows the dimension of the box of the mass M and the weight W at rest on the table. What is the pressure on the table due to the box? So the pressure is force divided by area. Now the question is how much force is exerted by this box? So definitely the force exerted by this box is equal to its weight divided by area. So the area of the contact, area of the box contacting the table is length and width. So Z length, Y width. So ZY or YZ divided by YZ. So the pressure is represented by weight divided by area. So W divided by YZ. So this is the option. D is the option. And the next, which graph shows the relationship between the pressure and the volume of the fixed mass of the gas at the constant temperature? We have done that P1 V1 is equal to P2 V2. So it means pressure and volume both are inversely proportional to each other for a fixed mass of the gas at constant temperature. Boyle's law. So for the inversely proportional relation, line must be a curve and will never touch any axis. So this is not the answer. This is not the answer. This is not the answer. So the answer is B. So do remember, this is the graph for the inversely proportional relation. In A, this is not inversely proportional. So we can say only when the volume increases, pressure decreases. So this is not inversely. When they are inversely, mean the product of both remains constant and the graph is a curve and it will never touch any axis, pressure and volume. So this is the graph for the inversely proportional relation between pressure and the volume. Next, the work done by the force F on the body is calculated by multiplying F by a quantity. Yes, work is equal to F into D, but which D? Which is covered in the direction of force. Mean force and distance covered, both are parallel to each other in the same direction. So what is Q? Q is the distance traveled in the direction of the force. So A is the option. Okay, the next question is a girl lifts an object of the mass 1 kilogram from the floor and puts it on the ledge 2 meters above the floor. How much potential energy? So the gravitational potential energy is equal to mgh. M is 1, G value is 10, and the height gained is 2. So the answer is 20. Very simple question. Next, a copper rod is heated at one end. Which statement describe how the heat transfer occurs in the copper? Look, copper is a metal. So there are two ways. Number one is the conduction. And number two, the movement of the free electron at the surface. So energetic copper molecules, no. Move from the cooler end to the other hotter end, no. Energetic copper molecule moves from the hotter, no. There is no complete motion, complete displacement of the molecule, no. Energetic free electrons move from cooler and to the hotter. No. Energetic free electrons move from the hotter end to the cooler end. Yes, this is the option. Molecules only vibrate about their fixed position, but the surface free electrons, they move completely from one end to the other end, from high temperature to low temperature. So in metals, if the question is in solids, only conduction. But if the solid is a metal, then along with the conduction, there is a movement of free electrons from high temperature to the low temperature for the transfer of the heat energy. So D is the option. Next, which heat transfer processes don't require a medium? Definitely the radiation, because the conduction occurs in solid, convection in liquid and gases. So no medium required for the radiation. Hence, the answer is C. Next, the list shows 4 properties, physical properties. How many of these properties can be used to measure temperature? So these are called thermal properties of a substance. And they are, number 1, length. Number 2, volume. Number 3, pressure. Number 4, electric resistance. And number 5, voltage or EMF. So these are in our syllabus. Now, mass not listed in these 5. Resistance there, voltage is there, volume is there. So they are 3 in number. So C is the option. So do remember, length, volume, pressure, resistance, voltage, these physical properties are used for the measurement of temperature. Next question is, the diagram shows a clinical thermometer. Which factor affect the sensitivity of the thermometer? Constriction, no. This band, no. The diameter of the bore, yes. The narrow bore diameter thermometer is more sensitive. The length of the glass, no. And the thickness of the glass, no. So the answer is B.